Hello, my name's Wayne Cullen. Today's video is going to be on the loss of neutral in a three-phase MEN system using our verification panel that we've used in a lot of our research and documentation and everything like that. So this replicates, as I say, the three-phase fixed wiring MEN earthing situation over 3 houses, but we're using a power supply of 12 volts DC. That's just because we've got all exposed actives and neutral links and everything like that. So it just makes it a lot safer. It still shows you what happens when you lose the neutral using the lower voltages and everything like that. So what we're going to do, we're going to get stuck into it. Everything's ready to go. We've got our little loads down here on each circuit. They're just LED loads just because it's the voltage is right down low. So if we turn on house one is as per the drawings that we have in all our documentation. It's got the copper piping, which is represented over here. This is our earth stake. The aluminium is your copper piping, your whole gas piping, all your metal, extraneous metal components. That's represented in this little section here. So it's laid out exactly the same as our drawings. You've got your yellow zone up here, which is your utility zone, and you've got your red zone down here, and house one's turned on, and we're using the lights and power. And this is house two. So house one is on A phase. House two is island mode. There's no copper piping. So island mode just shows you how once the copper piping is removed, you remove a lot of your earthing points inside your system. So your MEN is no longer multiple earthing points. It's only the one, which is this one over here, your earth stake. We've got our earth stake up here in house two. That's it represented up there. And we're just going to go through, so we'll turn the load on there. So the voltage started probably around about we'll turn them all off and we'll just show you the voltage. So you get a bit of voltage drop between houses when you turn things on, and that just shows you that the correlation between the houses on loading as well, not just faults. It's loading as well, so you're going to get as on the transformer and everything like that. Once you start to load up, it really affects what's going on in your three-phase system. It's balanced. We're just going to demonstrate and show you exactly what happens. So we've got everything ready to go. We've got our 12 volt supply confirmed. We're just going to disconnect this one up here. So we take out the main neutral. I've loosened that screw there before, but now the main neutral's out. Everything stays the same. The lighting down here works. The main neutral's gone, so your test button won't work on your RCD, and obviously being 12 volts, I can't show you that. So when we check down here, we put our probe on that, we get 12.7, which is a little bit, this one's on house 3, so we can see there is a little bit of difference. And this one is obviously lost the neutral up the top. So what's happening is it's lost the neutral there, so it's going all the way through this neutral over here, down, back down through, comes up through that point there. So that's why you got the voltage drop between that and that. Okay, so you can clearly see that. There's on 12 volts. It's only 0.4 volts, but that's in the scheme of things, it's big. So if we disconnect this main earth on house 2, this is just confirming the ring circuit on the neutral, and so nothing happens. If we lose the earth on house 2, nothing happens. See what happens when we lose the earth on H3, house 3? That's C phase on a 3-phase distribution system. That's 120 degrees from this house over here. So that's the thing. And when I tap that one or tap that one, we get power back here. And that's what happens with your lost neutral, and it shows. The risk is you don't know you've lost your neutral because your lights and power are on. But this is so dangerous because this point up here is live. It is completely live. So when we go down to say this point here, you get 11 volts. Right there, 11.1. That's because it's going through all these loads. So if we turn the loads off, goes up a little bit, goes up a little bit more. But you've lost your neutral. These houses have lost their earth, and yet on this earth, you've got nearly 12 volts on the earth. On the earth. So if we go to now, we've got 11.8. That's in the ground, that's in house 1. So that's on all your gas, on all your, any external, piping, any of your EV charging or anything like that. So if we take this one off here, this is our solar on house 3. So if we take that off there, look what happens. We get our load because we've reconnected this through the solar. That's how much power is going through this unit here. So if we put that back in, that's on the solar that's not even plugged in. So you've got 12.1 volts coming out of this supply here. And that's your solar switch there. That's just a single isolation switch. And so that's how we can see that on the 3-phase MEN system, the whole system is tied in. You've got your ring circuit through your neutrals at the top that drops down through your earth points here, here, and here. And with island mode, you don't have that. I can go from this one and I can try to get any earth point on this is your bathrooms, your wet seals, your where you've got no copper piping at all. There's no earth points inside houses 2 and houses 3. House 3 has an earth point through your solar, which is, we're going to look at that in the next video. So that's simply the whole loss of neutral. We've got that there. We've got our confirming our power. So I can touch that house there and the neutral's over in this house and it still lights up. That's just another indication of what, how intertwined the 3-phase system is. Thank you.